going to slowly rise, or it's called rebound in geology. And what happens with our rock units that are buried, we have rock units buried. What kind of rocks again? Layers? Sedimentary. And so erosion takes place and removes that. Erosion removes this. Now you've got two layers down below. The weight's been taken off. They're going to literally rebound. They're going to rise slowly. They're going to fracture along what are referred to as bedding planes. Your author refers to this as either unloading or exfoliation or sheeting. There are several terms used for that. And literally, in sedimentary rock units, fractures will develop along these seams. These are called bedding planes. And the bedding planes are zones of weakness, and that's where the fracturing will take place. Remember again, this is necessary for chemical weathering. Plants. We've all seen trees growing off the sides of mountainsides or sprouting through blacktop surfaces, and say, wow, look at that, the strength of a tree. No, it's really not that forceful. It's a marginal amount of physical weathering. What happens here is basically, if this is our landscape, trees up here, wind activity against that tree will cause the tree to sway this way, and it's a pivot point here. It's a wedge. It's a lever, in essence. So literally, the tree is moving back and forth like that, wedging it out, and the tree then grows to fill that void and over and over and over again. The tree is not growing and pushing it out, but it's the wedging process that moves the rock out that allows the tree to grow. Again, your author may or may not have included this, and so it's a significant one. It isn't. Okay, chemical weathering is a chemical reaction. So the end products look significantly different than what you started with. In physical weathering, the end products look the same as the original. In chemical weathering, the end products are significantly different than what you started with. Who's been in a cave? Who's been, great. Which one?
I don't know, dude. Oh, I was in the Mark Twain cave.
Okay. Which one? Okay, yes. Okay. Most caves, about 90+%, are in areas of limestone. So odds are the caves that you were in were in limestone areas. It becomes significant. Now, how did the rock get removed to form the cave? Where did the rock go? Obviously, there was a rock underneath there to begin with. The rock is gone, zap, you have a cave. Where did the rock go? And how did it get there? What are we doing?
Eroding.
Chemical weathering. Okay, the rock unit has undergone chemical weathering. Limestone, which is CaCO3, reacts with H2CO3, which is a very weak carbonic acid. What's H2CO3? We talked about it before. What? Okay, it's a carbonic gas, but where is it coming from? Where is it coming from? Where is this carbonic acid coming from? Our rain is not H2O. Our rain is a combination of H2O and CO2. So natural rainwater has a pH of about 5.6. That's not acid rain. Acid rain is anything lower than 5.6. So calcium carbonate and carbonic acid react, and this literally dissolves the limestone. So the first type of chemical weathering is called dissolution. It dissolves it. And the calcium carbonate then is removed as a solution from the caves. So all of these massive rooms in the cave, the limestone has been removed drop by drop by drop over millions of years. So again, chemical weathering. The material is dumped into various streams. The material is dumped into the oceans eventually, and it forms limestone again. It's recycled. Oxidation. Oxidation is the reaction between free oxygen and a mineral on the Earth's surface. Prime example would be iron. Iron oxide, you call it rust, whatever, is a form of chemical weathering. Hydrolysis. This is a chemical reaction between our weak carbonic acid, rainwater, and surface materials. Chemical reaction between rainwater and surface materials. What color is granite here in Marathon County? Red, pink, right? Red or pink? When that reacts with water, the end product becomes clay. What you're taking is something called orthoclase plus H2CO3, and one of the byproducts is clay. In chemical weathering, the net result is the sediments are less dense than the original. Chemically, they're far more stable than the original. They occupy a greater volume than the original material. And there is a reduction of color concentration. So chemical weathering produces a wide range of variations in the rock unit. The most important factor which influences rates of weathering is climate. Physical weathering far more active in cool, moist climates, except for salt crystallization. So here in mid-Wisconsin, most of the